Welcome. In this video, we're going to focus on the three forms of the linear equations and transforming those three forms into one of the other forms. So the first thing we're going to do is transform equations of lines into slope-intercept form. So we're going to take our point-slope form or our standard form and transform that into slope-intercept. So we want to finish with y equals mx plus b. To do this, you need to get y by itself on the left side of the equation. So we're going to use our knowledge of equations so we can manipulate it and get y completely by itself. So taking a look at the examples, our first example is given to us in standard form. So what we want to do is we want this y to be alone on the left-hand side. So what we will do is take our 2x and subtract that from both sides, where this will cancel out and we are left with just that y. That's exactly what we want, is y by itself on the left. And then looking at our right-hand side, we always want our x to come first. So we will keep the negative 2x and then it will be plus 4. We can't combine those terms because they are not like terms. We have our y equals mx plus b. That is now in slope-intercept form. Taking a look at example 2, we have an equation given to us in point-slope form. So in this case, the first step that we need to take is to get rid of these parentheses. We get rid of the parentheses by using the distributive property. So we're going to distribute the negative 2 to the x and the negative 2 to the 4. So we keep the y minus 2. That's now set equal to negative 2x, and this will be plus 8. Then we want to get y completely by itself. So we were subtracting 2. We want to add 2 to both sides. So that cancels those out. We're now left with just y on the left-hand side, which is great. That's what we want. Our 2 is a constant, so we're going to combine that with our constant of 8. So we now have plus 10. And we're going to keep the negative 2x. So now our slope-intercept form of that equation is y equals negative 2x plus 10. We have our y, we have our slope, we have x, and we have our b value. Go ahead and pause the video if you would like and give numbers 3 and 4 a try. So number 3 is again in point-slope form. So the first thing we need to do is distribute. So we'll distribute the negative 1/2 to both the x and the 2. So we have negative 1/2 x plus 1 equals y minus 4. We want to get y completely by itself, so we add 4 to both sides. That cancels those 4's out. We now have y by itself. We combine our constants, so we have negative 1/2 x plus 5. The last step we need to take is to make sure that y is on the left-hand side. So if we just use our properties, we can flip-flop our two sides. So we have y equals negative 1/2 x plus 5. That's the property of symmetry because we can flip over the equal sign and not change any values. So our final slope-intercept form of that equation is y equals negative 1/2 x plus 5. Then taking a look at number 4, we have a standard form. So the first step that we're going to take is to get the y term by itself. So we're going to subtract 4x from both sides. That's going to cancel out the 4x's. Don't lose this negative sign. So that has to be a negative 3y equals negative 4x plus 9. Now we need to get y completely by itself by dividing by negative 3. So we divide by negative 3, cancels out. We have y equals. Now we want to divide both terms by negative 3. So negative 4 divided by negative 3 gives me a positive 4/3 x. Then I take 9 and divide by negative 3. That's going to give me negative 3, so it would be minus 3. Our slope-intercept form of that equation would be y equals 4/3 x minus 3. We just transformed our point-slope equations and our standard form equations into slope-intercept. Now we're going to change our slope-intercept and point-slope equations into standard form. So first of all, there's a couple things we need to remember about standard form. First is that our A, B, and C values must be They must be integers. All right? We cannot have fractions or decimals. We have to have strictly integers. A cannot be a negative number. So A must be positive. So to do this, you want to get x and y on the left side of the equation. Then make sure that A, B, and C are integers, and make sure A is not negative. To do that, you can multiply both sides of the equations by the same number. So let's take a look at some examples here. The first example we have is given to us in slope-intercept form. Remember, the first step we want to take is to get x and y on the left-hand side of the equation. So we have y on the left-hand side. Now we want to bring our x's over by subtracting 2x from both sides. So what we have then is negative 2x plus y equals 3. Because our 2x is canceled out, we're left with just 3. And over on the left-hand side, those are not like terms, so we can't combine them. We just have negative 2x plus y. Now, before we say that we're done, we need to ask ourselves, are A, B, and C all integers? And is A not negative? Currently, A is negative, so we need to multiply both sides by negative 1 so we can make A not a negative anymore. So we multiply by negative 1. So on the right-hand side, we have negative 3. On the left-hand side, we distribute our negative 1 to the negative 2x. Gives me a positive 2x. Then we distribute the negative 1 to our y, which is going to give me a negative 1y, or minus y. So our standard form of that equation is 2x minus y equals negative 3. Taking a look at example number 6, when we look at this, the first thing we need to do to be able to convert this into standard form is to remove the parentheses. So we want to distribute the negative 3 to both the x and the 2. So we have negative 3x plus 6 equals y minus 4. Then we want to get our x and y values both on the left-hand side. So what we can do is we can add 3x to both sides, because that would make our x positive, which we need. So we add 3x. That cancels those out. Now we have 6 equals 3x plus y minus 4. We need to move this 4, so we want to add 4 to both sides. I'm running out of room here. So we have 10 equals 3x plus y, but we want our x and our y terms on the left-hand side, so we can use our property of symmetry and flip that over the equal sign. I'm going to write it up here. So our final equation in standard form would be 3x plus y equals 10. If you'd like to, you can go ahead and pause the video and give 7 and 8 a try, but be careful of those fractions. So taking a look at number 7, the first thing we want to do is get our x and y values to the left-hand side, so we can subtract 4/5 x from both sides. So that would cancel those out, and we're left with just 3 on the right-hand side. And on the left-hand side, we have negative 4/5 x plus y. Now, we're not done yet because we can't have our a value. It cannot be negative and it can't be a fraction. So we need to take care of both of those problems. To remove the fraction, we want to multiply by 5. And then to remove the negative, we want to multiply by a negative number. So we can multiply both sides by -5. So we distribute on the left-hand side. -5 times -4/5 gives me a positive 4x. -5 times the 1 in front of our y gives me -5y. So we have 4x minus 5y. And then 3 times -5 gives me -15. So our final standard form of that equation is 4x minus 5y equals 15. Number 8, the first step that we want to take is to get rid of our parentheses. So we want to distribute our 2/3 to the x and to the 4. So we have y minus 3 equals 2/3 x plus 8/3. Then we want to get our x and our y values to the left, so we're going to subtract 2/3 x from both sides. We also want to move the constant of our 3 to the right-hand side, so we're going to add 3. We can do both at the same time. So our 3's cancel out, and we have -2/3 x plus y equals, and then the 2/3 x cancel out, so we have 8/3 plus 3 gives me 17/3. Now, we can't stop there, even though we have our x and our y on the left-hand side. We need to get rid of the fractions in both our a value and our c value. We also need to get rid of the negative from the a value. So to do this, we're going to multiply both sides by -3. So we distribute the -3 on the left-hand side, and we have 2x minus 3y equals, and then 17/3 times -3 is -17. It's okay if our c value is negative. The only value that can't be negative is our a value. So the final form, in standard form of that equation, would be 2x minus 3y equals -17. Remember, if you have any questions about transforming the 3 forms of linear equations, talk to your teacher.